Oh, 25 November. Oh, so on Thursday, 25 November. Okay, okay, okay. Thank you very much. Thank you very much. Okay, so maybe we can start today's class. I think today's class is not so complicated, but maybe I need to ask you some important information. So let me share my screen. Okay. Okay. As always, welcome, Calculus crewmates. I hope there is no imposter among us. So today, this one is the attendance. I think I've put so many questions inside. I hope you don't bother to ask, like, if you done the quiz of chapter 3, the online quiz, if you finish all of it, and as always, which part that you don't understand up to now, and which number from chapter 3 exercise that you want to discuss today. And the last one, is that okay if you guys do homework that is further than the material taught in the class? Maybe I give you sometimes to fill in the attendance, since for now it's quite important information that I have discussed with professor. Maybe I'll explain later after you guys already fill in. Oh, I think that's already a lot of people join. You too. Hmm, 74. Okay, for the last question, some of you it's okay, some of you it's not sure. Some of you already done the quiz, but most of you haven't done it. It's okay, it's okay, it's okay. Ah, okay, okay. Hmm. Curve sketching. Okay, okay. Almost everyone feel the. Okay, so I think almost all of you guys has no problem with the chapter 3 material in the class. Okay, there's two numbers that maybe we can discuss in the class today. Okay, okay. Thank you very much. Thank you very much for the attendance. So, maybe I need to explain first. So, most of you haven't done the quiz. Yeah, 50-50. 50% of you guys already done it. I hope you have a good score. And most of you have no problem with the material. Maybe just need practice or some material from chapter 4. It's very good. And there's some numbers that we can discuss today. Okay, let's see later. And okay, some of you maybe don't understand what I mean from my last question. So, uh, last I think last week I've discussed with Professor Iman about uh, the condition of you guys in the class, and from what we've discussed, most of you guys have no problem with the material in the class, and most of you also has a good grades from for chapter 2 quiz. I think I don't know if in the system you can see the result directly in the end or not, but I have see all of your score from chapter 2 quiz, and all of you have been doing a great job. So cheers for all of you guys, and thank you. Uh, so I'm thinking like maybe some student also needs like slow pace from Professor Iman to teach the material in the class. So Professor Iman told me that maybe in this class I can make a question that further material than in the class. So let's say in the class you still teach about section 4.1. Maybe I can give you uh, homework from 4.2 or 4.3, so you can still keep up and you can have a new material. So later in the class, if Professor Iman already uh, enter the section 4.3, you already know it and you can discuss more detail about it. Because I think for now, maybe Professor Iman will take a slow teaching, because maybe some of the student need uh, more understanding about what happened in the class and what will you learn in the class. So that's the main purpose of what I'm asking from last question. Some of you it's okay, some of you are not sure, and some of you still asking what I mean. But I hope you understand what I explained before. So maybe within this week or next week, I will discuss still with professor. Do I need to give you homework or not? And if I give you homework, maybe I'll give one or two question that maybe haven't taught in the class. But of course, I'll make sure it's not hard question. But at least you have some understanding before professor teach you in the class. So I hope it's okay. And some of you want to ask some number. Maybe we can discuss some number today, since there are some of you that ask some number that we can discuss from what Professor Iman gave you. So let's see. Hmm. Video two. Wait. So there's three numbers, I think. The first one, I just want to make sure. Is it number 74 from review 2? Is this number? Number 74 from review 2. Let's see who asked this. Calderon Scarlet. Is this what you mean? Number 74? Yes, is that? Oh, okay. Number 74. Let's see if I also still remember. There's a lot of. If f and g are the function whose graph are shown, let px, fx, gx, kx, blah, blah, blah. Cx is the composition. Find A, B, C. Okay. With this function. Okay. It's quite long question, right? But it's okay. Number 74. So there's three questions that you want to ask today. I hope we have times to discuss about it. So let's do it together and I hope it can help. Okay. F and G function based on the graph and Px is equal to Fx Gx and Qx is equal to Fx G over Gx and Cx is the composition one. I think it's pretty easy. But let's see. F G X X. Okay. So the first question is P, the derivative of P with X equals to 2. P derivative of X equals to 2. I think it's pretty easy. So you just can put the function. So since Px is this equation, so the derivative will be P over X will be Fx times G derivative of X plus G. Sorry. Dx times for X. Okay. It's easy up to now. And just can put the 2. So okay, 2 will be F 2 G 2 plus 2 F derivative 2. Okay. From here, maybe let's make the so when f(x) equals 2, when f equals 2 here, where is it? This one. The f2 equals to 1. So you put 1 here. Times, remember that the first derivative of one function is the gradient. So you need, let me put the number here. So 6 0 0 plus, let me write it first and then explain. 3 minus 0. So at 2 first. When the first derivative of g, the function of g, at 2 here, is the gradient that happen along here. So that's why 6, the height of this one, divided by 3. Because the gradient happen around here is in this part, right? So if you want to know the gradient, you can use the function of the triangle. So 6 minus 0, which is the y, and 3 minus 0, which is the x, and you find the gradient here. Because the first derivative of the function is the gradient. And it's also applied here. When the first derivative of fx is the gradient from here to here, right? So 0 minus 3, 3 minus 0, yeah, it's the same. And since it's from top to bottom, so it's minus. 0 minus 3, 3 minus 0. And you will get 1 times 2 plus 4 times minus 1. You got minus 2. Okay. So I think it's pretty easy when you do for the QX and CX, since the X is always the same too. So you can just use the same number and just follow the function. Okay, is that clear enough? I hope. Got it. Okay, thank you, Scarlett, for your question. Next one, page 272, number 104. I'm always scared with big number, but let's see. Oh, 272. 104. Okay. This one. Is it true? I think it's Jack, right? Jack as this number, page, yeah, 17, number 104. Let's discuss water skier, skis, blah, 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 over the ram. This one is the ram. Shown in the figure at speed of 30 feet per second. How fast is she rising as she leaves the ram? Okay. It's pretty interesting. Interesting question, but let's see. Actually, I'm quite nervous since I believe you guys here, almost of you, no, all of you are very smart. So if you ask question, it must be hard. And I already forgot some of these, but let's see. Okay, so this is the RAM. Let's just throw the RAM first. Sorry for my bad drawing. It's 50 here. I don't need to put the unit. Okay. This one is 4. And she goes with the speed of 30 feet per second. But what is this? We still don't know. But let's say from the figure. One thing for sure, let's say this one is X. And this one is Y. And this one is Z. So whenever the water skier skis over the ramp, so this girl here is skis over this section with the speed of 30 feet per second. Okay? So we know that this one is the, since it's speed, you know, the speed is the derivative of the range. So this is dz over dt. Of course, we don't know. At least I don't know where the speed of 30 feet per second is where. Oh, so he goes from here to here. The speed is 30 feet per second. Since it's in the z part, the z side, so 30 feet per second is the dz over dt. Okay? Nah. Okay. So, from this point to this point, the water skier goes with the speed of 30 feet per second. And the question is, how fast is she rising as she leaves the ramp? So when he goes here, how fast this part here? So another dz over dt, right? Oh, sorry. Dy over dt. Since it goes to this part, how fast it goes from here to here. Okay, so we need to make sure the equation first by use the triangle. Y over C is 4. If you use the Pythagoras equation, since I think it's pretty good number, the Z will be the Z will be 241. It's pretty easy, right? 15 square times plus 4 square root. You get this one. Okay. And from here, you put Z over here. You got 4 times 1 times Z. And since this one is the one that us, which is the dy over dt, we can derive from here. So it will be d y over dt for 1 dz over dt. And you get from here 30. So you will have 4 for 1 times 30. So you will get 120 over 2 for 1. It equals around 7.7 something. Feet over sec. So how fast is sea rising? So rising means the velocity between the water skier height to the water level as sea leaves the ramp, which means it's dy over dt. Okay. I believe the one that asked is Jack, I think. Jack, is that clear enough? I hope. Oh, I think there's 2 questions. Still 2 questions. Okay. Okay. Thank you. Thank you. Thank you. Next one, chapter 3, review 2, number 71. Okay, let's see. Number 71. Oh. Let's see. Oh, Ryan, you asked number 71. Is this one, right? The one that you mean? Yes. Okay. Let's see. Oh man, it's okay. We can discuss about it. And by the way, if you don't understand or etc., you can tell me. But from what I see from number 71, it's quite long. So please bear with me. Let's see number 71. Okay. If fx blah 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 blah, show that f the derivative of fx over fx is equal to this one. Okay. So it's proving. This type of question is proving. So let's see if we can prove it. I hope we can prove it. So I hope it's pretty. I think it's pretty, but I don't know. Let's write first. Oh yeah, remember guys, don't forget the process. All of you have no problem with hard question, but Professor Iman always told me that make sure that you always follow the process so you can understand which part that may be still wrong or something. It's over c times x minus c. Okay. So when you use the derivative, since the question is they want to find the derivative, right? So the derivative of this one will be what? Anybody knows? Anybody knows? XC. So we can use product rule. So let me write it first. It will be like this. X minus b times x minus c. If this part times this part. Plus, will be quite long. X minus a times x minus c plus x minus a x minus b. Okay, TA, how come you know this one? Oh, sorry. Okay. So TA, how come you know this one? It's because, and if you remember the derivative of the product rule, if x equals u times v, it will become u v plus u. So from this, you will always add the function. Oh, maybe I will write like this. So if x u times v times w, it will become, you need to derive every function and times with the remaining one. So it will become, maybe I can write like this, u times v times v derivative plus u times v derivative, u derivative v times v. This is f x. So that's why you can get this. And then you just can put the function. So fx over f, fx equals to, you can put here to here, divided by this one. So let me write it again. X minus b, x minus c, plus x minus a, x minus c, plus, it's quite long. It's a, x minus b over, sorry for my bad line, x minus a, x minus b, x minus c. Okay. And then if you divide, you will get the same width. F x f x, you'll get 1 minus x minus a plus tada. Okay. Is that okay, Ryan? Okay, you're very welcome. You're very welcome. Maybe for of you guys, maybe we can discuss later. But if you already understand, you can do it. It's just like a mystery question from me. You can prove this by using natural log function. So if fx equals to x minus a, x minus b, x minus c, you can have this same result if you put ln here. And then you put inside, and what happened. But I give it all to you. Maybe you can solve it, and if you haven't solved it and you still want to know, maybe I can discuss later next week, maybe. Just remind if you want. Okay. I think there's one more. 116 by Nick. Is it true, Nick? Is Nick here? Nick us number 116. Whoa! Really? You asked the last the last question? Let's see. Show that the length of the what? It's okay. But it's okay, it's okay. Is Nick here? Are you really ask this question? 116. Man. It's quite scary. But let's see. Show that the length of the portion of any tangent line to the asteroid function cut off by the coordinate axis in constant. This one is quite long. Let's see. I think this one is quite long and a lot of proving. but I'm not sure if we still have some time. But maybe I want to ask the class. I think this one is quite long, and there's a lot of explanation. Can I can I put the solution for this number 116 in the Moodle? Is that okay? Or you still want for me to answer this number here? Maybe Nick. Where is Nick? Oh. Okay, I think she's not here. But maybe for this part, number 116, there's one of you guys that asked for number 116. Maybe I'll put the solution in the Moodle. Oh, I'm here. Oh, no. It's not. Eh? Nick. No, it's Nick with the student number 114. Maybe he already left. Yes, the question from 116, this part. Since it's quite long, maybe I'll put the solution in the Moodle. I'll send you to you guys the solution, and maybe you can learn from that. And maybe before I close, is there any question? I think that's only four question, but I'm sorry that I think I explained quite slowly, so I cannot finish the last question. But I will give the solution in the Moodle, so just check out the Moodle for this number 116. And maybe for last time, is there any question from you guys? Okay, thank you. So thank you for joining the class, and don't forget to just always check out the Moodle. Maybe I will discuss later with professor. Maybe I will give you some homework about chapter 4 so you can be ready for the midterm. And for all of you guys that haven't done the quiz, yeah, chapter 3 quiz, Chayo, I hope you have a good score like what you have from chapter 2. Because most of you is have a good score. Very good, very good. So if no question anymore, so I think we can leave faster. Yay. Thank you for joining the class today. I hope you have a good day. And see you next week. Bye bye. You're welcome. You're welcome, Ren. Bye bye. You're welcome. You're welcome, Scarlett. You're welcome, Ifando. Bye bye.